Hello. So we're looking at Zustand today. I guess that's kind of how you pronounce it. It's a state management system for JavaScript that I think is trying to position itself as smaller, less complicated than maybe what people are using for React. It says here that it's state management for React, and maybe that's what they're up to. Something React specific, and you can see an example here. All right, so let's dig in. We see somewhere that it is, again, mostly TypeScript and a little bit of JavaScript and no CSS or HTML or whatever, like we've been seeing. We've seen, let's see, we looked at Redux before and we've looked at React. So we've seen some state management before, and based on the code snippets, it looks like this is going to be pretty similar. This is a cool picture. Okay, so here's an example of how to use a store. So this is just, we're importing some stuff, and then create, you're going to pass in some lambda that takes a variable named set, and creates this. I guess this is like a dictionary, and the bears is essentially an int that's by default set to 0. And then we have this increase population function that will take that is defined to be a lambda. It looks like taking calling set and passing set another lambda, where the lambda takes the state and just increments the bears counter that was defined here. And then remove all bears is just calling set with setting the bears to 0. So I don't know where set is coming from. I guess set is the set that we pass in here. So when we call create, I suppose we name this function or something like that. And then you bind it to your components, which by calling this use bear store thing. Again, you pass it a lambda that sends state to state.bears, essentially getting the value of bears and storing this function call as a variable. And then you pass this, essentially you pass the function into your, I suppose this is JSX style templating or whatever. All right, so that's kind of how you use it. Let's take a look at how it works. I feel like everything has to be in source. We have README, but README is not in all caps, which I think is will get you sent to GitHub jail. No, obviously GitHub doesn't care. That's such a strong convention. Okay, so in source, we have middleware, React vanilla, context index, middleware, more middleware, React shallow, traditional types, and vanilla. Vanilla, traditional, it's kind of seem like synonyms. I assume that index.ts is one of the important entry points. I don't know what shallow, I don't know what the rest of these do. I guess just pop these open. Did we already open React? I don't think we did. Context might be important. And then I guess we can just peek at what's in these folders. So vanilla just has shallow. React just has shallow. And middleware has combine, DevTools, Immer, persist, Redux, and subscribe with selector. We're going to guess subscribe with selector is basically some subscription mechanism where maybe you can pass in something like a regex or something to match, and maybe you'll only get messages that match. I guess we'll open all of these. Can't hurt. I feel like this is a pretty small project so far. So let's see. All right, index.ts. I guess if I program more JavaScript, this would be obvious, but this is just essentially the export statements. Here's vanilla. I feel like vanilla is not the place to start. Where is maybe context? Let's start with context. So we have commented out code. Why? This doesn't work in ESM because React libs are CJS only. The following is a workaround until ESM is supported. I don't know what ESM or CJS are, but let's look this up. CJS, maybe CJS common JavaScript. ESM maybe ECMAScript something or other. ESM to CJS compiler. Yeah, but so common JS seems to be CJS. Is ES like ECMAScript? Yeah, I guess. What is common JS? Is that like another standard? Is a project to standardize the module ecosystem for JavaScript outside of web browsers. Okay, so some JavaScript standardization stuff. All right, so we are importing React exports. So this does seem to have a core dependency on React. Right, and we're also importing the store API from Zustand. But I feel like I didn't see the store API defined anywhere really clear. So maybe we can dig that up. Okay, and we're also from traditional, we're importing use with equality function. Okay, and then we have, I guess this is just getting these maybe React exports as local variables. Then we have a type, use content store, which extends the store API of unknown. So it's a store API essentially of any, you can store anything in it, I think. So let's just verify that the unknown type is the any type. Let's ask Google. Unknown is the type-safe counterpart of any. Anything is assignable to unknown, but unknown isn't assignable to anything but itself. And any without a type assertion or a control flow-based narrowing. Stack Overflow. Right, so there's unknown. Yeah, whatever. I just read that. So if we have this vany, we'll set it to 10, and unknown is 10. We can sign string to vany, but signing string to unknown is invalid. So I guess there's a little bit more type safety for unknown. Cool. All right. So I'm gonna still think of it as the any type because that's really what it is. I mean, not not if you do JavaScript, but like in type theory, it sounds like any doesn't really obey type properties. Okay, so we have a store API of whatever you want, and I guess this is defining an extract state thing, which seems like an object rather than a function-like thing. And it's parameterized by S, and then we get a separate parameterization by U. I'm not sure what these two things, or maybe these are separate entries. I'm not sure. At any rate, we have some selector and inequality function. I'm going to ask, I guess, ChatGPT about this syntax. Hello, Aditya. Aditya, how goes it? So I'll say, tell me about this TypeScript syntax. In particular, so what was I confused about the extracts? Okay, so what kind of object is extract state? Really, what is its type is what I want to know. So blah blah. So this unit type map to extract state of S defines a function signature that takes no arguments, okay, and returns an extract state of S. Extract state is another type that's expected to be defined elsewhere. Fine. And this is something that I think I understood. And then the use selector, blah, 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 defines another function signature. Okay, so it's just a separate function. I guess, do we just get that from it being on a different line? Because there's no like terminating thing here. All right, so this is another function that takes a selector function and an optional equality function. Okay, it means that the function can return any type u. The selector function takes the state of extract state s, yeah, and returns a value of type u. The optional equality function parameter is a function that compares two types of value u. Okay, so then how do we know? In terms of parsing, how do we know that u starts a new function rather than continuing the definition of extract state? I'm going to guess it just has to do with the fact that we can kind of bind this all to this colon, or maybe just significant white space, the new line tells us. When you see u following a function state, it indicates beginning of a generic type parameter. The u blah, blah, blah after the colon. Yeah, okay, I knew that. Yeah, I don't feel like you understood my question, but that's fine. Thank you. R? I didn't know you could give yourself a single letter name. All right. So I don't remember where we were, but yeah, we were done here. Okay, so we have this extract state thing, which is parameterized by S. And I guess we're saying S extends something. I'm not sure really what this should be like type, like inference, right? I mean, inheritance, I guess, essentially. But it extends something that doesn't seem to have a name. Instead, it's this get state. It's this curly braced thing, enclosed function get state, which takes, which has this like arrow function notation, like a lambda notation, that takes the unit type and returns an infer t. And I guess it's checking if we can infer the type, then we return it. Otherwise, never. I'm going to ask ChatGPT what's up with this syntax. I'm sure this is recognizable to TypeScript people, but I just want to make sure that I, for things that are this, it's kind of like telegraphic or like code golf. Okay, so let's see. So this part checks whether type S has a property get state. Oh, okay. So S extends get state is a Boolean. Is that what this is saying? So this is really all parenthesized. Maybe? Which is a function that returns some type T. The infer keyword is used here to capture the T that the get state function returns. So I guess what it's saying is like, if S extends this thing, really this is a type checking thing. But like in the world of duck typing. So like if it has this property essentially, then this is just the ternary operator. So if it has this property where we can get the state, then we're gonna set some variable here, extract state of S to the type T. Otherwise it's set to never. What is the never type? I'll ask, is never a type in TypeScript? It represents the type of values that never occur. Okay. So it's like equivalent to this shouldn't happen. How is this different from the bottom type? It's closely related, but they are not exactly the same. In JavaScript, never is a type that represents values that never occur. The bottom type refers to the most to the most specific type in a type system. Is a subtype of every other type. Okay. All right. Okay, so we have this never type, so this should never happen, I guess. You should never be able to define extract state. I'm not sure. I think ChatGPT just told us, but I glossed over it. But maybe this will throw some error if you try to use this in a way it's not supposed to. So, okay. And then we have this other type. So it seems like so far we're getting is some interesting type theory machinations where we're using, sorry, not type theory, interesting TypeScript machinations, maybe a little bit of type theory, but um, it's using, it seems like it's like leveraging the type system to do programming kind of at the runtime level as opposed to the compile time level, which there really isn't that much of, I think, in TypeScript. All right, so without call signature, it again takes a type, and we have k and key of t. So t is the type, right? And we're setting it to t of k. So I think this is maybe like a list comprehension. So for everything that's a key of t, I don't know. I guess we'll go back to ChatGPT. Whoa. I'm glad to know I can do that, but I think I just pressed the wrong button. All right. So the k and key of t is a mapped type. It iterates over each property k in the keys of type t. So it does seem like a list comprehension iterator thing. It constructs a new type. For each property k, it simply copies the type t of k to the same property of the resulting type. This function essentially creates a new type that is identical to t, but removes any call signatures, function types from the properties of k. So for example, if t has properties with call signatures, aka functions, I guess, like this, example type, foo is a thing that sends the unit type devoid, bar is a thing that sends x, which is a number, to a string, then the without call signature will produce a type equivalent to foo is a void and bar is a string. So essentially we get the return types. Yeah, only the return types. Okay. This can be useful when you need to manipulate types and want to strip away function signatures, perhaps for serialization. So I want to think about this a little bit more. So for every, I guess, type map to iterate, for every property in T, we're going to, the type T of K, I don't understand how this removes. So how does, I guess we're learning about TypeScript today. How does this remove, what's it called? What do they call them? Function types? Zustand? Wait, Zustand, I see. You stand, you said, you lay down. That's good. I like that. All right. The expression does not specifically, it simply creates a new type that has the same properties. Oh, okay. So we're, I guess it doesn't really remove anything, and it just, we would need other syntax to get, their call signatures. So I'll ask, how would I, if I had this function and I decided I actually did want the call signatures, how would I modify it to also get call signatures? Actually, a better question is probably just how would I get just the call signatures? So I would do this key of key and type tk. Okay, I would check that it extends function, and then I would get tk. All right, fine. That's just how to how to work with TypeScript. Okay. Okay, so then we have this thing that's deprecated, so we'll ignore it. So what is it? Create context is deprecated. I'll keep that in mind. And create store and use store should be the way that we use contexts. So we have this use store API, which takes in, I guess, a void, and we're gonna return some stuff. We're gonna call use context on Zustand context, which is maybe like a global context, and get a store. If we don't have the store, we'll error out. If we do have the store, we are going to, it seems like, use memo, which I'm going to go out on a limb and assume it's just memoization of this without call signature of S. I don't know where S came in. I don't think we've defined S here. So maybe this is just templated by S, I guess. And we're going to have this function that with this dot 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 store notation. I think it's returning a tuple, or rather, this lambda returns a tuple. One is dot 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 store, which I feel like I've used before, but I don't remember what it does. And then one is the list, is a list containing only store as the item. And then whatever this is this, are we still in the deprecated function? We're going to return provider, use store, context store, and use store API. I guess this is more, if it's deprecated, we don't really need to concern ourselves with it. But we might as well figure out what the dot 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 stuff is. It's known as the spread operator. It takes all the properties of the store object and spreads them into a new object literal for creating copies and clones of copies. Okay. It's a React hook to use. So the use memo thing comes from React and it's used for memoization. Fine. And then the dot 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 is doing some sort of shallow copy, like splaying open store, I guess. All right. So not that. But did we see? So where's the deprecated warning? It says use create store. Is this the React create store? Instead, use create store, use store from Zustand. What are they defined here? Let's see if we can do a, oops, let's spell it correctly. I guess it's maybe in vanilla. Whoa. All right, which is where we're heading next. So let's head on to vanilla. All right, in vanilla, why is it called vanilla? I don't know. We have the set state internal, which I'm going to guess is the internal version of set state. And we have partial and replace, which is a Boolean, I guess, whether to replace the thing instead of doing what, I'm not sure. And partial, I'm going to guess, is going to be a little bit like partial function evaluation. It's either a T. So we have the set state internal, so we have to tell it, I guess, what type of state we want to store there. There's some type T. So it's either that type, or it's a partial of T, or it's this thing, which I think is an object. It's a thing that has state of type T already, I guess. This is maybe like something that already uses state. Or it's a partial of T, which I thought we already had here. Are these different? I'm not sure. But, oh, no. Okay, so here, this or is inside of this, this curly brace block. So whatever this is doing, this is some other way of saying that we have a kind of like a T, but it's maybe wrapped in something else. And then we have this emoji, which I think is just supposed to be a literal underscore. Why? I don't know. I guess maybe some underscore is often in languages used as a kind of soft indication that something is private. So maybe the type here is supposed to be private in some sense, and we're pulling it out. All right, that's set state internal. We have store API, and this should be just the API. It's an interface, which I'm going to guess in TypeScript is similar to interfaces in other languages. Essentially, an abstract thing. So we have the APIs. We have set state, get state, setters, and getters. Set state, I guess, has the type of set state internal, which I think is maybe just some. Oh, here's the here's the underscore thing. I think this is defining a function, a void function called underscore. And I think that maybe this is saying that we can take a thing that already has this underscorey thing and get its type or something like that. And then I don't know. I'm not sure what this is doing. I'm not going to ask ChatGPT about all the syntax, but more or less that seems to be what it's doing. Then we have get initial state, which is going to be of type T, the T that you asked it to store. And we have the subscribe function, which takes a listener, and the listener is a thing that takes in a state and a previous state and returns void. And the subscribe function, I guess, returns a function that returns void. So why would a listener return void? I guess the listener is doing some side effect as opposed to returning a value. And I'm not sure what state and previous state is. I'm guessing state is maybe you're listening for a particular state, but I don't know how previous state is supposed to affect your subscription. Maybe we'll see. Maybe we'll see in a bit. We have this type get, which is triply parameterized by a type K that extends key of T, or rather, if K happens to be a type that extends key of T, which I think means that K is a property of T, then we're going to set get to T of K. I guess you call get, you say I have, bears and I want their population or something like that. And this is saying like if population is something that bears have, then we're going to return bears of population. Otherwise, we'll return F, which is maybe supposed to indicate like a failure type, or maybe it's like a default type. And then mutate. Export type mutate. Takes an S and an MS. And if number extends, where's number? Is if number extends MS, I guess we try to get length and key of length. I'm not sure what that means. I feel like this is trying to say that MS is something that has length, which is a number. But we'll ask ChatGPT about this one. Then, so if I guess I'm going to read this as if MS is like a numbery thing, then we're going to return S. Otherwise, well, I feel like this point, I don't think that the ternary operators are really adding readability. I feel a little bit like this is maybe not optimized for being readable code. I feel like this is a little bit optimized for trying to be succinct as possible. And maybe I don't know in TypeScript if there's a benefit to that. I don't know. I feel like the compiler that compiles to JavaScript should at least be able to optimize simple things. But like for something like this, because we don't have, like, for example, closing braces, we have to try to figure out from a given line, like where the beginning of a conditional is, for example. But anyway, we're chaining these ternary operators. So the next thing to do is check if MS extends, I guess, the empty list. And if it does, no. So if it, yeah, so if it does, we get S. And if it doesn't, I guess we check if it extends the infer M, whatever MI and MA are. Where do they come from? I'm not sure. And then we have this dot 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 infer MRS, in which case, and if it does extend those things, then we have this mutate store mutators, S of MA. Yeah, I'm not sure where like MA and MI come from. But let's just ask about this syntax. I'm mainly interested in like what this number extends MS of length thing. So it's a condition. Okay, so this is a type. It's a conditional type used for mutating state based on the series of mutations represented by the type MS. So S is the type we want to mutate. MS is this type representing the mutations to be applied to the state S. Okay, so we have a state and some mutations. What does it call it? A conditional type. And so here are the conditions. If number extends MS length and key of MS, this part checks if MS has a numeric length property. If it does, it means that MS is an array-like object. In this case, mutate SMS evaluates to S, indicating that no mutations are applied. This checks if it's an empty array, and there are no mutations. If it extends infer MI MA, never. This part is the most complex. It checks if MS is a non-empty array with elements in the form MI MA rest. Okay. Each element MI MA represents a mutation, where MI is the mutation identifier and MA is the mutation arguments. So MI and A, these are, I guess, being defined here. And it's doing some sort of pattern matching syntax, I guess. And so I guess a mutation has the form essentially is a list of two elements where we have a mutation, some identifier, and then the arguments, I guess, to the mutation. So if it has this form, I guess via pattern matching, then we think of it as a list of mutations. And then what do we do? If it's then okay, we call mutate on the store mutators of SM with the MA arguments and the what did it call it? Like an indicator, identifier, and store mutator identifier. I don't know if and is if single and is Boolean and or bitwise and. And I guess it's not bitwise. And then whatever MRS is, and the MRS is like the rest, I guess. So we've like taken the head of the list, maybe somehow. And if M doesn't match this pattern, indicating an invalid mutation structure, the result is never. Okay, so but that doesn't answer where did number come from. What does number do syntactically in this thing? Hello, Struct. Thank you. I am doing well. I hope you guys are all well too. The number serves as a type to compare against. Okay. All right. So essentially, we're checking if it has a length, I think, and if that length is numeric, which is more or less what I think I said we were trying to do. Okay. So that's what it's doing. I guess the syntax is probably familiar to TypeScript people, but this is, I guess, some sort of extends with a list, somehow it does pattern matching or something like that. All right, and if we have, and then we also have this type state creator, which takes a T, some MIs, which I guess extend the store mutator identifier, and some unknown type. The MOs, which also maybe mutate in, mutate out. Anyway, we have two things that are seemed like lists of store mutators with an unknown type, and then some type U. I'm not sure what U would use stands for. Oh, U is equal to T, I suppose. Um, and the state creator has this get state, set state, and store. And store has type mutate of store API of T Ms. And get state also has Ms. And who has Mos? So somewhere down here, I also don't know what double $ store mutator question mark Mos. So whatever Mos is doing, I'm not sure. But this is essentially some fancy way of saying that we have these set state, get state, and store things, and they might, I guess, mutate stuff. Then we have create store, and we have this big type. This is a big type signature parameterization thing. We have an initializer that's going to have type state creator of T empty list Mos. So when we call create store, we pass in the type and this thing. This is the mutator. So if we go back to maybe just the GitHub README. So the bear example. When we don't call create store using Zustand without React. Okay. So I guess that's what vanilla means. It means that there's no React. So store, I guess, is being set to create store. And this seems like it's just passing in one argument. Is that right? This is create store uppercase. And this is create store lowercase. I'm not sure. But I think that the maybe if we go back to the React example here. Something with bears. What? I think this create thing is maybe somehow delegating to the create store method that we just saw. But let's see if we can compare it. I'm not sure. I think maybe what I'm trying to say is I think a mutator is something maybe like increased population that's going to is going to receive an identifier maybe, and what you need to be able to do is say that you need to be able to reach in, given the syntax, you need to be able to find where bears is defined and set it to a new thing. And I think that's the sort of thing that the mutators are trying to do. Because if you look at this, this function looks like it should define a new dictionary, essentially, a new JavaScript object. And so you need some code that's going to look at the object that you define here, and when increased population is called, get this new object, compare it to the existing object, and make changes. And I think that's what the code that we're looking at is doing in some sense or another. But maybe we can find the create store that is lowercase. So okay, so create store is a type here. We have create store impl, create store impl lowercase, which I guess is the function version. We have set state. Did we use set state lowercase here? you have use bear store, and and the increased population calls use bear store with a function. I don't think we used set state explicitly, but if you can find create store, maybe export const create store. Yeah. So create export const create store is a function that takes a create state, and if the create state is non-null, maybe, then we call create store implementation on the create state. Otherwise, wait, where does this single parenthesis end? Here, I guess. Otherwise, otherwise, I guess we create store is equal to the create store impl, and then as type create store, which is the type we saw above. So when we call create store, we might pass in a thingy, and the thingy here is set. So, oh no, wait, what? This is create and not create store. Okay, well, we haven't quite gotten to the create yet, but let's take a look at here's traditional. Is this React? How is traditional different from vanilla? We have extract state, read-only API with React. So maybe this is Reacty. Import React exports from React. And what do we do? Do we do that here? We have no references to React. So I'm going to guess traditional means with React. And let's see if we can find a create function. Export create. Or export const create. We have create with equality, create store. I'm not sure. We're getting close on time, so I don't want to. I want to at least be able to map what I see in the example to something. Does GitHub give me this? No, I don't want that. This? We have types. I just want the export. So we have use store. Do we have function create store? Or rather function create? We have the create type, which has more of the mutators and stuff. We have create impulse. So this seems like react.ts follows vanilla.ts pretty closely. Here's traditional.ts. Do we have create here? No. Let's see. Here's combine. What is combine going to do? We have an initial state, an additional state creator. I guess this is combining two state things. Immer has a thing that takes a type and some mutator identifiers, and maybe it's creating an immersion. It has an initializer. It's going to take in. Yeah, I don't know what this is doing. I'm going to guess this is maybe like trying to put one inside the other, but let's look that up. Zustand Immer JavaScript. Immer middleware. The Immer middleware enables you to use immutable state in a more convenient way. Okay, so not immersion, but immutable. Why immer? I don't know where the ER comes from, but this is some sort of immutability thing. Persist, I'm going to guess is storage, like persisting to some sort of storage. To where, I'm not sure. JSON, some JSON file. Okay, we can ignore that, I think, pretty safely. Redux, this is probably some sort of compatibility with Redux. Redux implementation. We've got a reducer and initial. Maybe this is their own implementation of reducers. I don't know if we import. anything from Redux, like the famous Redux library. I think this is maybe their own implementation. They have a dispatch thing, which takes a store, a Redux store, I guess, and maybe like calls the dispatch method or something. And the Redux is a thing that takes a type in action and probably like a command essentially. And then you reduce the state in the type in the action. So that's standard reducer reduction stuff. Subscribe with selector. I was just kind of curious what whether this means that we are like modifying subscription with in some way with like some sort of predicate, but I'm not sure. So it takes a T and some mutators, and it has an initializer, which is a state creator. And what? And we call state creator with T MPS and the string literal subscribe with selector and never. And I guess the remaining MCSs, or rather, I guess this is like the shallow copy thing. And I'm not sure store subscribe with selector. But where's the actual selecting getting done? But here's the implementation. So it's going to be a thing that takes a function that returns. We're doing these chaining, like this chaining of functions. I'm not sure like how I'm supposed to read this, but it seems like it takes a function that returns get set and set get an API. It returns a function that takes the set get an API, and this is the implementation of the function that gets returned. So we get the return type of the function, and we have some listener. And we have the original subscribe, and then I guess we're gonna. Where did selector come from? Somehow we get the selector, and let listener equal. So if there's no selector, we'll set the listener to the selector. If opt listener, I'm not sure where opt listener comes from. I guess there's some equality function, and we're getting the current slice is being set to the selector of the I guess the current state, and we'll set the listener to be a function that takes the state, and here we go. If the current slice is not equal to the next slice, then we set the previous slice to the current slice and call opt listener, setting the current slice to the next slice and the previous slice. Yeah, I'm not sure. But somehow selector, so selector is called here. So we're calling the get state, and selector is doing something. I'm not sure. I guess selector is a type that takes an any and opt listener, and so it takes an any, it takes an opt listener, which is also an any, and it takes options, which are also any. So it seems that a selector is pretty much unconstrained. So I'm not really sure what that code is supposed to be doing. All right, but what I really wanted to do before I go is see if we can find this create function, just so we can, hey, do the thing. There you go. To see if we can find where it, what its implementation looks like. I'm going to guess that it somehow is delegating to the functions we looked at. So maybe let's try function create. Oh. How about just create? We have type create. How about export create? How about create equals? Yeah, here. Const. All right. So create is equal to this thing. It's we've got this arrow function lambda thing um, that takes in a type. I guess a function. I'm not sure, not sure what this syntax is. So we've got this type parameterization syntax, and then there's a tuple. Maybe this is a function signature that takes maybe it takes a create state, which is a state creator or undefined. And if create state exists, we use create impl, calling it on create state. Otherwise, use create impl, I guess, with no arguments as a create. And then create impl does what? We take the create state and we possibly import stuff on every call to create. That's a little bit surprising. And we maybe do some warning if we're not in production mode. If mode is not production and create state type and the type is not a function, and then we get a warning: passing a vanilla store will be unsupported in future versions. Okay. Then we set the const API to be the type of create state, to be whether the type of create state is equal to a function. Oh no, sorry. If the create state is a function, because I guess we no longer support whatever it was before that we did, then we'll set the API to be create store of create state. Otherwise, it's just create state. And then use bound store. It'll be set essentially to use store of the API and the selector and the equality function. And then we'll call it whatever object assign is. Maybe that's a JavaScript thing. Assign use bound store API, and then we'll return use bound store. So that I think tracks pretty well with what we see. So create, we're giving it this thing, which is some sort of essentially just one function, right? And that function should be of type. Again, I'm not sure how to read this, but this should be, I think this is saying this is a function signature. Maybe. Let's ask, you stop this. Let's ask ChatGPT about this syntax. Okay, so create impl, yeah. It declares a constant. Yeah, a constant what though? It should be the implementation function. So T is a generic type. Parameter name create store. Here, state creator is a generic type that takes 3 arguments. T is the first argument. Yeah, and then 2 empty arrays, right? So the constant is a function that takes a parameter named create state, which is expected to be of type state creator. The T indicates that the function is a generic function, meaning it can operate on different types of T. Okay, so this is just, at least according to ChatGPT, is just saying that we are entering the world of generics. And this is the actual signature. Okay. So the create impl takes a create state thingy, which is of type state, state creator of T and some empty lists. And I guess that's what this is ultimately supposed to be. But where is state creator? The state creator has a type and some mutations and a U with a set state, a get state, and a store. So I'm not sure. I think that these seem to be mutators: increase population and remove all bears. These are things that mutated. Um, I'm not really sure how to map this to what I'm seeing here, but mostly just because I don't know the the TypeScript syntax. Because this to me looks like create is taking a single thing. Was it const create? Oh, we jumped to a new file, I think. Whatever. Try one more time. Const create equals. Yeah, in React. So this should take this thing. So the thing that we're passing in must be somehow a state creator. But how it is, I don't know. Is this the only? I don't know. Is this the only implementation? So somehow that must be what's going on. Let's take one more look at, I guess, create state. Or state creator, that is. Oh, I see. We imported state creator from vanilla. That's how we got into vanilla. All right, I'll just ask ChatGPT to tell me about this type. Yeah, so we have the state type. We have the mutation identifiers paired with their corresponding arguments. Yeah. Represents an array of initial mutations. How do we know they're the initial ones? It's optional and defaults to an empty array if not provided. Yeah, doesn't the other one too? Yeah, and u equals t, this parameter represents the return type. It defaults to the state type if not. Okay, so this is just saying that u is t by default. So that's the return type. And the state creator type is a type alias representing a function signature. Yeah. Set state, a function responsible for updating the state, is obtained by extracting the set state method from the mutated store API, get state, and store. So I'll ask if this function, so let's see. So I'll tell it about this. So consider this implementation of create. And this call to create. Is this a valid call to the create function? So yes, it is valid. So in the create function, to invoke the single argument, which is a function. This function takes a set argument and returns an object. Yeah. The object returned from the function includes properties such as bear, increase population. Yeah. Given that the argument provided to create matches the expected signature of state creator, where t is inferred from the type, this is valid. It creates a store named bear store. So given that the argument provided to create matches the expected signature of state creator. So where is state creator? Up here? Yeah. So this is, I guess, this is just saying this is like bookkeeping. And then the function itself has this oh wait, we have the set state, get state, and store. But doesn't this seems like two setters? So I'll say explain how the argument to create matches the state creator. Whatchamacallit, signature. Yeah. So set, get, and store is the mutated. So store is the mutated store API. Okay. This function takes a single parameter set, and the mutation function set is used to, yeah. These properties represent the initial state and mutation functions of the store. That's right. Because it's a function that takes a set parameter. Uh, understand how the argument provided to create matches the state. Okay. State creator is a function signature that takes three parameters: set, get, store. Okay, but where are the get, state, and store parameters in the call to create? Just okay. You just wasted my time, ChatGPT. All right, so I'm not sure. There must be maybe another create. Thought I was losing my mind for a second there. How to reset state. So maybe it's in some other thing. Maybe const create equals. I don't know. There's React. There's testing. I'm not sure. There's some sort of stuff going on under the hood. I think you have to know. Maybe if we had more time, we could dig more into all of the different implementations of create and kind of try to dig things out. But my impression is that is arguably some of the least readable code I've ever read. So it's all. It seems like they're trying. The It seems like it's trying to be like very abstract and terse. And so it's certainly hard for me as someone who doesn't know TypeScript to read, but that's not so bad. There's all sorts of stuff that would be difficult for me to read, just because I don't know the language. But it seemed like, for example, with the chaining of the ternary operators, and it seemed like they were trying to get as much on a single line of code as possible. That makes it very hard to reason about. And for example, even ChatGPT got confused about whether the thing that we were calling matches the thing we were trying to call. So it reminds me of this C++ book. I forget what it's called. It's like a red book about I don't think it's any of these. This guy, Andrei Alexandrescu. Alexandrescu. Um, so if you find a copy of this book, it's like how to program in the C++ type system. And so it does all of these like type level programming, and it's just like totally insane. It's a fun read, but it felt a little bit like that's kind of what this package is trying to do with the type system, which is not bad, but it is a little bit hard to reason about, and that the hopefully that's backed up with lots and lots of tests, because if something's difficult for people to like quickly spot if things are wrong, then you really need a lot of tests make sure that you've constrained the behavior of the system, um, and not have like subtle bugs that can be, low. They may be bugs that have a low probability of triggering on most code bases, but when they do trigger, they can be like impossible to to figure out, that sort of thing. Um, so that's where I'll leave it there. Um, I see something. Are you going to investigate Spring source code? Maybe at some point. It's not in the plans. I think I'm going to. I've committed to looking at the JVM itself. But I'm not sure exactly when that will be. But I'll leave Zustand there. I'm going to do a stream on Prettier in just about a few minutes. I'm going to take a break, maybe about 2 minutes, and then I'll jump back on. All right, see ya.